This is Apollo Control at 134 hours 10 minutes. We have about 47 minutes 30 seconds before losing contact with Apollo 11 as it goes behind the moon in preparation for the trans-Earth injection burn. The burn duration will be 2 minutes 28 seconds. That will add 3,284 feet per second to the spacecraft velocity, starting it on its path back to Earth. And we would consume about 10,000 pounds of propellant with that burn. A splash would occur, according to our preliminary figures, just about precisely as predicted in the flight plan.
On the sixth day of its journey, Apollo 11 began its return to Earth. A total of 2,100,000 kilograms of propellant, 90% of its total weight, was required to escape Earth's orbit, and 4,500 kilograms were now used only for re-entry into the Earth's atmosphere. The Apollo program itself totaled an equivalent of $64 billion in 2023 money, with an average cost per launch of $1.5 billion. If we compare it to any other rocket built until now, Saturn V still stands the test of time and is still, as of the beginning of 2024, the only rocket to send a crewed mission to the moon. The challenges in design and engineering for such spaceflight, including life support systems, were indeed remarkable. With humanity's desire and need to accomplish more in the field of space exploration, the question of sustainability arises. How can space exploration become less reliant on Earth's resources and on public funding and flourish in the context of a future in-space economy? I'm Hanna Siemaszko and you're listening to Resourceful, a podcast which explores the exciting new opportunities of space resources. Resourceful is produced by ESRIC in collaboration with SciLux.
Space exploration and space operations is something that most of the time is not the best friend of sustainability. I mean, when you're talking to people, even in the street, like if you ask someone, what do you think about going to the moon? A lot of people will tell you, okay, I don't know why you're doing this and we just don't get it. Let's take care of the Earth. You know, that's really like the answer that you get most of the time from people who are outside of the space world. And this is something I can understand, right? Because we have so many problems right now. And so you say, okay, why going there? And actually, I think this is very important to say that space can really help sustainability on Earth as well.
This was Najwa Naimy from the Exploration Company, and here's Daniel Faber from Orbit Fab.
Sustainability can be defined in a few different ways. Environmental sustainability is, of course, what most people are thinking of now. There's also the question of economic sustainability, which in the space industry is always a big question as well. There are many great plans to explore and settle space. Only a few of those are economically sustainable. So I take a holistic view. We need to protect the environment so that we can keep operating there long term, but we also need to make economically sustainable exploration, development, settlement of space so that our activities can expand in the space arena.
The first recorded opportunities for humans to clearly see distant stars and planets happened at the beginning of the 17th century. A couple of centuries had to pass until the first astronauts landed on the moon in the late 1960s and 70s. But in the meantime, humanity hasn't ceased to be fascinated by space. This vast and mysterious playing field holds clues about our place in the universe, and while it raises philosophical questions, it also offers numerous practical opportunities.
When the space age started, space was just very large and very empty, and it was such a challenge to do anything in space it wasn't as much of a problem to just leave junk floating around in space. People have now realized that that time is over. There have been a number of collisions of space debris with active satellites.
For example, in 2009, two satellites, a functioning and a retired one, collided, leading to the destruction of both. For more on the topic of space debris and circularity, stay tuned for our dedicated episode. We have invited Daniel Faber, the CEO and co-founder of Orbit Fab, to tell us more about refueling in space. Orbit Fab was founded in 2018 in Colorado, USA, with the goal to eliminate the single-use spacecraft paradigm with in-space refueling.
If you want to remove debris from orbit, like if you want to have a garbage truck, you really need to refuel it. Otherwise, you launch your garbage truck, you tow a couple of pieces of debris, and then your garbage truck either becomes debris or has to be thrown away. Right? You have to refuel things in orbit. We have to reuse them. Everything right now is stuck on this single-use paradigm. Everything's a throwaway object. Rockets used to be like that, and SpaceX and now others are looking at making rockets reusable. At Orbit Fab, we want to make satellites reusable so they never have to be thrown away again. But once you have that, you can take it a step further, because if you can do garbage collection, you could also run a junkyard, a recycling center. You start to bring in new economic models that nobody's had. You start to be able to extract resources from the moon and asteroids, which takes a lot of fuel, but then also produces fuel. You can reduce the number of launches that we would need to get to orbit for a given amount of economic activity. And so we can increase the intensity of economic activity in space without linearly increasing the amount of launches and the potential harmful effects of those. So there's a lot of things that fuel in orbit really helps in terms of sustainability.
We have asked Najwa Naimy, responsible for vehicle design and product strategy at the exploration company, to tell us more about the importance of opening space up to non-traditional players and design solutions that are reusable and versatile, reducing space junk and fostering a sustainable approach. Najwa told us more about NIX, a modular and reusable orbital vehicle that can eventually be refueled in orbit.
So I think that space is currently one of the most closed technical and scientific fields, right? And here the idea is that we want to make it more accessible to everyone. Historically, space access in general was done for space stakeholders, right? I mean, you could only send something into space if you were yourself a space company or a space stakeholder. Here, the idea with the exploration company and with NIX, the vehicle we are developing, is to open these doors through different aspects. The first aspect is, of course, affordability. I mean, if you want to democratize access to something, it has to be also accessible from the financial standpoint, that people can actually afford to send something into space. Then the second aspect is information. If we take the example of our first demonstration mission, which is called Mission Possible, that should fly this year, we have on board 15 customers that are sending some payloads into space, and we have more than 50% of them that are not space companies. So it's really like to open the doors to unleash the power of space that is way more than space-oriented. Normally, the first power of space should be to improve life on Earth.
Our modern lives and paths on Earth rely heavily on activities taking place in space. The future promises to bring interesting new opportunities for science and technological advancements. We need to approach it with great creativity and seize the chance to transfer the know-how between terrestrial and space applications.
Just to explain how insanely expensive it is to get something off the ground, right? You think the rocket is expensive. There's a lot of technology there. When we've launched that, we've just thrown away the rockets at the end of the day. It's like building a plane to fly to Paris and fly to New York. You get one flight and then you throw the plane away. That's what we've been doing previously. Now with SpaceX, with the new launch companies, we're building reusable rockets. So at least we don't have to throw them away every time. But they have to come back to the Earth to get refueled.
Reusability is really one of the most important features of our vehicle. I think in the company, Of course, there is like the profitability aspect, that's for sure. We know that reusability is one of the top enablers to this. And right now we see in the field of, and the landscape, let's say, of the vehicle, the space vehicles that are docking to the stations, we see that the one that is the most affordable right now on the market is the only one that is being able to be reused.
Low Earth orbit cargo vehicle called Nix Earth will fly to space stations around the Earth, come back to Earth, and be reused.
The concept of reusability is different from Nix Earth to Nix Moon. So Nix Earth, you are coming back to Earth. You just refurbish the vehicle and then you get back again on the launcher and you get to space. For Nix Moon, it's different because at least for the first missions, we're not planning to come back to Earth yet. So here it's more about extension of mission. So basically, let's say that your first mission with Nix Moon is to get to the lunar surface. Then the idea is to say, okay, but we don't want the mission to be finished at this moment. We want to be able to extend the mission of Nix Moon so that it can potentially hop on the lunar surface from one point to another, get back to the lunar getaway, for example, and then here to be able to do this extension of mission, which is in some way reusability, because it means that you don't have to send a new vehicle again to do the next mission, but you use the one you already have on the lunar surface. Then it brings a lot of complex concepts, right? Which the first one is obviously refueling, because most of the time when you're launching from Earth, you're optimizing as much as possible the reserve of propellant that you have for your very mission. Okay, not now, but certainly in the next step, use in situ resources, and that's for sure that it will be one of the enablers. And then in terms of reusability, something that is very difficult for Nix Moon is that you don't have the eye contact. You're not able to inspect visually the status of your vehicle once it has landed on the moon. So you need to develop some high complexity technologies to have all the data you need and all the information you need to say, okay, Nix Moon, you are clear to go to the next step of the mission. And this is really something different when you have the vehicle that is like that far away and you don't have any contact visually with it.
In science fiction, space travel seems to be pretty easy and often requires having something called space drive or star drive. The fact that a spacecraft is mainly carrying fuel does not seem to be its prominent characteristic. Nor is it clear how come the spacecrafts have unlimited fuel and can go wherever they please. So let's look at reality and start with the basics. What is fuel for us in space?
Yeah, that's a really good question. What is fuel? And Orbit Fab is adopted the tagline of gas stations in space. It's a bit of a misnomer. We're not selling gas. This is not fuel that you might put in your car. The main thing you need in space is, it's better described as propellant. So let me step back and break down what we're talking about here with propulsion, with moving satellites around. So this is not launching rockets. When you launch a rocket, you're trying to get out of the gravity well of Earth. You need something that is very fuel efficient because gravity is very strong. You need a lot of, we call it delta V, change of velocity. You need to accelerate really hard to get out of gravity. And so there are different things that are used for that. Once you get into space, you need to be able to hold that propellant for a long time. Satellites can operate sometimes up to 20 years, usually 5 years or more. So you need to have propellant that is storable. So that means that the cryogenic propellants like liquid oxygen, liquid hydrogen, liquid methane, which are great for rockets, aren't that great in space.
There are two classes of propellants, chemical and electric propulsion.
The fundamental difference is where the energy is coming from so that you can push this material out the back as fast as possible. The faster you can throw the material out the back, the faster you'll go forwards. Like the more fuel efficient that will be. And in a world where we've only had one tank of fuel on every satellite, it's almost unthinkable how much that pushes you to be trying to be as fuel efficient as possible. Imagine if your car had one tank of fuel. You would want whichever fuel gets you the furthest, and you would pay extraordinary amounts to get fuel that could take you even further, just a bit further. We have to start by lifting everything from the ground on a rocket. And we're not a rocket company, but you can buy access to rockets. And so we buy rides to put our material into space. And then we're really doing storage and distribution. That's where we're starting. But in doing this, we're establishing that people will take like a gas cap for satellites. That hadn't existed before. So we developed the gas cap, and people are now integrating that into their satellites. Once the satellites have that, we establish the operations, the ability to deliver that fuel. So we build up that expertise, that technology. We build our customers' confidence that exists. Effectively, we're building a market for fuel in space. But what we want to do is deliver that as cost effectively as possible, as cheaply as possible for our customers. And while the cost of rockets are coming down, they're always going to be expensive. If we can get the material in space and we don't have to put it on a rocket, that's much, much better. And so the rocket is hundreds of tons of propellant. Remember, this is liquid hydrogen, liquid oxygen, the best chemical propellant that we've got. High thrust, pretty good fuel efficiency. You have to push the engineering to such an extreme limit that 100 tons of fuel gets you 1 ton of payload to orbit. Now, we're launching fuel to orbit, so I have to buy 101 tons of fuel and I get 1 ton to orbit. That's a terrible ratio.
Enter space resources.
The moon has resources, and the moon is much smaller than the Earth, so the gravity to get off the moon, the fuel you might use, is much less. And because there's no atmosphere on the moon, you can actually build effectively a big slingshot and accelerate something off the moon so you don't even need fuel. You could just use the electricity to run an electrical slingshot. Or if you look at asteroids, there are millions of asteroids, and they have almost no gravity at all. You don't really land on an asteroid, you dock to an asteroid, right? So we can take that material. What we then need to do is to turn it into the propellant that we want to use and put it into an in-orbit supply chain into that market so that we can sell it. That is the step Orbit Fab is building, delivery and supply. Then upstream, the space resource extraction, that's really the exciting stuff that will come once the market's been proven.
Now that we've established how unsustainable bringing the propellant is, let's focus on the types. Hydrazine-based propellants currently dominate the satellite scene. However, the main issue with them is that they are highly toxic and can cause many serious health issues to people.
At the moment, satellites use both the chemical propellant, the hydrazine is the most common, and the propellants for electrical propulsion, where xenon and krypton are the most common. But Orbit Fab is focused on hydrazine. We're focused on that because it's the dominant fuel that's used in space. It also has a lot of advantages. It can be high thrust, so you can move more quickly. So you can get into business and start earning money more quickly for the commercial operators. For others, you can just do a lot more things in a time frame that makes sense. And there's a whole class of propellants called green propellants. They're called green because they're less toxic than hydrazine and sometimes less chemically aggressive. So it's easier to contain them, it's easier to move them, it's easier to handle them. A lot of folks in the space industry have got comfortable with hydrazine. We have processes so that we can handle it, but it would be nicer to just not have to deal with that toxicity level. And therefore, these propellants called green propellants are really less toxic propellants. The problem with those is they have a viscosity and dissolved salts and various issues that do make them difficult to refuel on orbit.
Hydrazine is currently what most companies would rely on to refuel satellites. However, the exploration company wants to only use green propellants for their capsules. Najwa explains.
We're using propellant that are absolutely non-toxic, so we're no longer using like this historical propellant that we're using before, like hydrazine for the moon missions, like the big engine that we need to develop. We're using LUX methane. It's more complex than LUX hydrogen, but this is something we can do. And also why we're doing this is that, of course, this is non-toxic for like the people who are going to operate around the vehicle, like during the ground filling, etc.
In just about 60 years, we managed to reach a record of 5,000 active satellites circulating the Earth. Our lives are gradually more intertwined with satellite communication. We use GPS to get almost anywhere, depend on it for weather forecasts, and soon might even get internet access mainly from satellites. The number of new satellites continues to increase, and so does the need to change their orbit not only to correct drifting, but also to avoid collisions. Looking at the rising congestion, we need to realize that Earth's orbit is a finite resource. Bearing in mind that on average a satellite remains operational for 5 to 10 years, working out solutions for future mission disposal is vital. In this context, refueling satellites seems to be a logical option. So what took us so long to investigate it further?
So why haven't we been refueling satellites? The answer is we've lacked the technology. We haven't had effectively self-driving spacecraft. There's now a lot of technology for self-driving cars, and you think how complex that is. We can put that into satellites, and there's no bicycles and trees and pedestrians, so it's a little bit easier, but you're not on a road where everything's nice and flat. You can move in 6 degrees, and you can't hold onto the road, so you're constantly drifting, and you have to correct for this drifting. So it's complex. There's a lot of math. There's a lot of work being done, but now we've reached the point where that technology is mature. And so that started companies that were looking at doing servicing, like the tow trucks and vehicles for delivery and inspection and even repair. A few companies like that started up. And about the same time, we started saying, hey, how about you get fuel? We'll do the fuel supply bit. You do the tow truck. We'll do the gas station. So it's incomparable, the value of the fuel for use in satellites versus the value of metals for use on the ground. There are a number of problems, though. No one's buying fuel in space yet. Right? And we made this realization 10 or 15 years ago, and I'm not the first person. People have realized this well before I did. But there's no market. That's the biggest problem. Nobody's buying. So there's no price that's been set. We don't know where to deliver it.
With technology becoming more mature and legislation on the topic of in-situ use of space resources being more and more integrated at national levels, the field seems to be ready soon for the future in-space economy. If we look at the use of resources from the moon and asteroids, we can sense the great potential to serve as an essential catalyst for various activities that go beyond space exploration.
Yeah, I mean, space resource by nature is an enabler. I mean, you can make a very, very great use of it, but that's also very complex. I think that if we want to be in a situation where in the end we're able to extract and produce methane, because that's what we're going to use on next moon, I think it takes a lot of partners that are actually specialized in this, that will be able to settle there, to have the right technology, and to develop it at such a scale that it will be usable for us. Because right now, in the projects we'll see, the quantity is quite minimal, right? But we would need a lot more quantity, so that the scaling is, for me, something that is yet to come. So this is something that we have in our vision, like long-term vision.
The International Space Station is scheduled to retire in 2030. For a very long time it was our only off-world home, and soon it is likely to be accompanied by another continuously crewed station. And this is just the beginning. Quite a few commercial stations around Earth are in the planning phase, and there's also Lunar Gateway. Thought to be the follow-up to ISS, Lunar Gateway will orbit around the Moon. This effectively means establishing our presence 1,000 times further than now. It also means supporting the future robotic and crewed exploration of the Moon and beyond. Good news for Najwa and the exploration company. All these stations will definitely need to be constantly resupplied.
Docking to space stations and resupplying space stations is our core business. That's the ultimate goal of Next Earth. I see Lunar Gateway as a real enabler for the space logistics around the Moon. And for me, that will be a first step to extending that to beyond the Moon, let's say. I think it will be an angular point of the space logistics at that moment in the future. I think it will be also a very good opportunity to resume collaboration between countries, which I really hope is an opportunity that the world will be able to take and to consider. And for us, it will be really an enabler, because we know there will be a lot of needs in terms of resupplying. I have no doubt that the space stations will come to reality. It's just a matter of time, right? So having also these opportunities to have free flyer missions, to have customers from private space or non-space industry that want to be on board and demonstrate missions, then this is a bridging market, actually. You can do a lot with it while you're waiting for the space stations. Honestly, I think things are moving super fast.
Examples from popular culture often portray space exploration as a rather sci-fi activity, where geopolitics appear as an obstacle. While innovation is oftentimes rooted in imagination, reality on the ground and in space aims to be different. Space is an opportunity for collaboration, creation of strong ecosystems and exchanges.
For me, the unique aspects of Europe that we can actually use for space exploration is that collaboration is at the very DNA of Europe. We see it like trying to team up together, even if we don't have all common interests, but we're trying to find compromises, emphasizing like international partnership as well, because Europe is not only Europe and self-centered. Most of the time, Europe is actually one of the only, let's say, entity on Earth that is still able to have good communications with a lot of different other countries that are actually themselves not communicating at all between each other. So it's also, for me, a very good media, Europe. I think that we have seen as well that Europe politics is very aligned with sustainability targets, right? So I would say that this is very much aligned with Europe politics and DNA to try to contribute to a global effort for responsible space exploration. That's really collaboration and indeed like responsible oriented. You want to send something into space, then you go through NASA or ESA programs, and you get hopefully a spot on board International Space Station, maybe in 5 years from now, and this is very much expensive, right? So here the idea is that we turn into, let's say, a more like streamlined, a more standardized, a more industrialized way of actually selling space. And here, what I'm saying most of the time is that in my team at the exploration company, I have also the mission management section. And mission management is basically you have a new customer and you spend a lot of time with this person to actually define the interfaces between their payload and the vehicle. What is the mission? What are their constraints, etc.
What awaits is new science and surprising discoveries. Low gravity in space offers a completely new environment for scientists and industry. Now the task is to follow the accelerating pace and create new business opportunities. Those who manage to be on board will be at the forefront of space exploration and the in-space economy.
Roger, 0G, and I feel fine. Capsule is turning around.
What's happening today is that we're getting access, industrial type level access, to zero gravity. We get to take the gravity out of the jar. And we have no idea what you do with a jar with no gravity, let's be honest. We know a couple of things. We have some ideas. We just don't have enough experience. But you can remove buoyancy. There's no separation. So you can mix oil and water and they kind of stay mixed. You can mix lead and lithium. You can alloy those two from completely different parts of the periodic table. The densities won't cause them to separate. We will slowly move all manufacturing off of Earth, not just because it will pollute the Earth less, but because we can do things that are going to be more valuable to do in zero gravity. And then people will go with it. People will like living in space. I'm sure there's a lot of work on biological research and development, medical solutions in space. And so perhaps space is a better place to retire because you can dial gravity down a bit and it'll be more comfortable. Who knows, right? These are things we don't know. But all of these things are going to create a push for more and more people to be living in space. That's why I'm very bullish about it. But ultimately, the reason that the economy in space will be bigger than the economy in Earth is just space is so much bigger than Earth. You think Earth is big. Earth is a tiny dot in the solar system, a tiny dot. So it's just a question of time. I'm bullish. I think it's 50 to 100 years.
After all, that's what innovation is all about. Daniel compares the current situation to the microchip revolution.
If you went back to the 1950s and asked somebody about manufacturing microchips, you would have the same thing. There's nobody using microchips and there's nobody making the things that are needed to make microchips. These days, it takes $10 billion to create a microchip fab. That's a lot of money. That's a lot of incredible equipment that is needed to make one production line for microchips. That grew up over 50 years. That expertise. And it created a lot of wealth, right? A lot of value was created. Silicon Valley exists exactly because of that. We're now looking at the space industry. It's a similar opportunity. It's a bigger opportunity. You're right, none of it exists. That's why we need entrepreneurs coming into this. This is the opportunity that is in front of us, is to build all of those companies in that ecosystem. That's why I'm excited. The challenge is to find the thin ends of all of those wedges. How do you start? What is the seed? It's an exciting time to be in the industry because we can see so much happening and so much changing quickly.
We are building future. In 1 year, your part will be there in space. And that's something that is really great. If I compare to the space industry when I started 12 years ago, it was super slow. Everything was slow. And I think before I arrived, I think it was even worse, right? But now, I mean, you see all the projects that are coming out, and this is more and more prototyping, this is more and more demonstrators, you see more and more hardware now.
The beauty of exploring space, no matter how far you go, you're only ever just beginning. And the same is going to be true for the space economy. No matter how big it gets, we'll always just be beginning. We'll always be able to expand further.
That's really, for me, the exact best moment to be a startup in the space industry right now.
We rise together, back to the moon and beyond.
Be part of the conversation. If you enjoyed the episode, share it with your friends and subscribe to our channel. If you want to find out more, follow us on social media and join our annual Space Resources Week conference. Until the next episode, stay curious. This series is brought to you by the European Space Resources Innovation Centre, ESRIC, supported by the Luxembourg National Research Fund, FNR. It is produced in collaboration with SciLux.